Hello, today I'm presenting my personal finance manager project for Python assignment. This project demonstrates a complete REST API built with Flask and SQLite, featuring statistical analysis and linear regression for income forecasting. This is my folder structure. Here I have wrote a detailed version of it. This is our Flask application entry point, and this is our database. These are the requirements we need for this Python project, and in the README file we will find all the installation and running procedures. I have already activated the virtual environment, and I have also installed all the required dependencies. And for running the project, we have to run this command. And now our Flask server has started. It is running on 5000 port, and our debugger is also activated. Let me first show my database schema. I have implemented all three required tables using SQLAlchemy ORM for account, transaction, and income. First, the account table with ID, name, currency. These are for relationship with transactions and incomes. In the transactions, all the required fields and relationship with account, and in income, all the required fields and relationship with account. Notice the relationships. When you delete an account, all related transactions and incomes records are automatically deleted through cascades. This ensures data integrity. We have already started our Flask application. So for the API demonstration, I will go to Postman. In the Postman, I have already created an collection Finance Manager API for all our API endpoints. In the get all accounts endpoint, we can see that there's no accounts currently stored in our database. So I will create a new account with the ID A1. So a new account has been created. If we check again, we'll find that account in our database. Let me add another account, A2. Now we will find two accounts. We can also search an account using the ID. And also we can update the account. In our original account, the currency was foreign. Now we want to change it to euro. And we have updated successfully. And if we search again, the foreign has been changed to euro. And if we want to delete an account, let's say we want to delete the A2, account has been deleted successfully. If we check again, we'll see there's only one account. Next, we want to add some incomes. For January, we have added a salary with 3 lakhs. For February, we have increased the salary 20,000. And if we search, we'll see 2 incomes. We can also search a single income. We can also update using the ID. So for the first income, I1, we want to change the amount. We want to increase the amount 10,000 more, and we also want to change the source from salary to salary plus bonus. And now if we check again, these 2 fields will be replaced. We can see that these 2 fields have changed. And if we want to delete an income, we can also do that. For that, I will add another income. I will change this I3 to I4. Now we will have 3 incomes. Now I will delete this one. Income deleted successfully. If we check again, we will see only 2 incomes. Next, we will create some transactions. For transactions, let's change the date to January 10. Transaction 1 for account 1. This is income type transaction. We also want to add some expenses. Let me add another expense. Okay. Now if we check all the expenses, we'll search like this. We got 3 expenses, but if we want to filter a specific date range, let's say January 1 to January 10, we can also do that. And in that case, we'll get only 1 transaction. We can also search a single transaction. And we can also update the transaction using ID. Let's say I want to change the second transaction amount to 7,000, and I don't want to change the category, or I want to change the date. Okay, now if I check again, I want to change this. The second transaction's amount have been changed to 7,000, and the date has been changed also. So next is our statistics. This endpoint demonstrates statistical analysis. It calculates maximum, minimum, mean, median, standard deviation values. So we search, we also get our transactions by category, bonus and food. As we have two transactions of food category, those two were added together, and we also got the stats. We have three transactions. Maximum is 50,000, minimum is negative 7,000, mean is 12,000, median minus 5,000, and standard deviation is 26,000. We can also search here using a time frame, specific time frame. If we want to search till January 15, our food transaction will be different, and so as our stats. So here we can see that the statistics have been changed. And next is income forecast. Also, this statistics use Python's statistics module. You can see the implementation treats the income as positive and expenses as negative. Next is linear regression forecast. This I'm requesting a 3-month forecast based on historical income data. Here's the historical data, January and February salaries, and here are the prediction. The linear regression model detected the upward trend and forecast continued growth of about 10,000 per month. This uses Scikit-learn's linear regression class. The model aggregates income by month, fits a linear trend line, and predicts future values. Let me show you the codes now. Oh, also before that, I want to show another thing, which is if I delete account, all the incomes and transactions will be deleted too, as I have added all the incomes and transactions for A1 account, so everything will be deleted. So if I delete this one, then there will be no incomes, and also there will be no transactions. Let me go to the statistics service first. Notice how I handled income as positive and expenses as negative. Here I calculated mean, median, standard deviations using Python's statistics module. This provides comprehensive statistical analysis as required. Next is forecast service. I import Scikit's linear regression. First, I aggregate all incomes by month. Then I prepare the data. X is the time index and Y is the income amounts. Next is here the linear regression training. Model fit trains the model on historical data, and this is where we make the prediction for future months. And finally, we predict the next n months. I also ensure prediction can't be negative. Now I want to show the Flask routes. Here are the API endpoints, one for statistics and one for our forecast. One for forecasting, and this simply calls the services I just showed and return JSON responses. Let me go through the other files quickly. Here are all the manager files for account, income, and transaction manager. Here are the functions that are necessary for CRUD operations. Here are the three models: account, income, and transaction. Here are the routes for account. These are the CRUD routes, income, and transaction. I have already went through this one, and I also went through the services. And in storage, here is the DB connection. Finally, let me run the automated test to verify everything works correctly. For this, I will open another terminal and run this command, test api.py. In the test API, I have written some tests for our CRUD operations and also income forecast. These are the also for summaries. These are the CRUD operation for account. Also, if account is not found, update operation if account is not found, delete operation if account is not found. Same goes for incomes and transactions. So after running the test file, we can see that all the tests have passed, confirming full CRUD operation, statistical analysis, and linear regression forecasting. Our forecastings are working correctly. In summary, this project demonstrates a complete REST API with 20 endpoints, full CRUD operation on all three database tables, statistical analysis with mean, median, standard deviation, and category breakdown, linear regression, income forecasting using Scikit-learn, and all built with Flask and SQLite following clean architecture principles. Thank you.